Good morning, everybody. Oh my gosh, nice to see. It's so nice to be here early on a Monday morning. I'm really happy that, honestly, that I didn't forget, because Monday's my worst day. But no, I wouldn't forget this for sure. I want to just introduce myself a little bit. I asked OpenAI to make a picture of me in a red shirt speaking to UNT Eagles in a classroom. And this is what I got. You can tell we go to the same gym, right? Probably not. But it did get the pants right, and this is what it thinks you look like. So a bunch of Eagles, except for this one human here. I'm a developer. Although that's not my full-time job, my company does a lot of development work. I spend most of my time consulting on technology for companies in a wide variety of industries, but we started in e-commerce, and those were my roots, is in e-commerce. That's how I got involved in technology. I speak several different languages just because of my background. I started my career in Europe. I went to an MBA program in Milan, and then I lived in Germany and France for a while. And languages kind of were something that also got me into technology as the translation became better and better. I got involved in it early on, and I actually helped with the development some of the language translation software that we were using in Europe. And then I am definitely family man, 4 grandkids, 3 kids, getting started. But I think probably the most important point in my career at this point was when I got sick of my job and I rage quit. Now, this is not actual footage of me rage quitting, just in case you're worried about that. I was in a job. I hated it. I was the chief marketing officer for a company that I really didn't respect very much. And it was a rather large company, but I decided that, after being in one more meeting, kind of getting raked over the coals for no reason in this meeting, I just quit the meeting. It was a webinar. Sent my boss an email saying that I was out, and then I had about 15 minutes on the drive home to figure out how I was going to explain this to my wife. But I got there, and everything was fine, and that was in 2009. So as you can tell, things worked out. And shortly thereafter, I formed this company called Razoyo. And Razoyo started in the e-commerce space. And we kind of have this branding thing where all of our employees get a little image, a little monster assigned to them. So these are actually sort of an assortment of our employees. And if you go to our website, you'll see that. Cameron, and I'll introduce my team. So Cameron, who sat in this class 6 years ago, something like that, was an intern with us from UNT in the e-commerce space. And she did such a good job in her internship that we hired her a couple of years ago. She's been with us ever since. She's a project manager and also handles most of our marketing. So we're really happy to have her with us, but e-commerce and this program have really been kind of a part of the foundation of Razoyo because Cameron was, I think, the 6th or 7th intern we had from UNT in a long line of interns. So, and we were really, really happy with the interns that we got because they actually knew something about e-commerce and they could be productive right away. And for us, like that's really important because as an agency, we kind of sell our time, and so we all have to be productive all the time. So it was great. So the title of this is AI and E-commerce, Armageddon, Utopia, or Business as Usual. It's a good question. How are things going to work out? Is AI going to just like replace all your jobs? Is it just going to be a big problem for everyone? Or is it going to make life beautiful and easy and create a utopia for us? I can actually eliminate one of these 3 right away, and I'm sorry to say it's the utopia one, because when things get better over time, as they do in technology and business, expectations rise, competition increases, and so you're never at the end point. You're never at this like beautiful ongoing thing. You know, I have a friend of mine when I worked in PepsiCo who was one of the head salespeople at Frito-Lay, and he one year won the top salesperson award out of thousands of salespeople in PepsiCo. And they had like a little ceremony, and we went to this dinner and kind of celebrated him. And I was talking to him afterwards, and he says, yeah, that lasts about 15 minutes. And now I have a new quota, right? And now it's next year, and I could get fired next year. So life is never a utopia, but it is a great journey. So let's talk about now our two endpoints, Armageddon or business as usual. But before we get into that, let's define some terms. And I'd like to appeal to all of you. Does anybody want to define the term e-commerce? Because you're in like an intro to e-commerce class, right? So have you defined this term yet? You want to tell us? Yeah. What's your name? I'm sorry. Latasia. Okay. Doesn't have to be word for word.
I was going to say like anything online.
Okay.
In online shopping.
Making a purchase online shopping. Anybody else have a?
I think it's the process of when you add something to your cart until the checkout.
Until the checkout.
Yeah.
Okay. So e-commerce is up until you get to, that's an interesting one. I haven't heard that one before. Anybody else? No? Okay. Well, let's talk about where e-commerce started. So this is like an early telephone, obviously. It doesn't even have a way to dial it, right? This is the one where you pick it up and an operator answers and transfers you to somebody. But you could use this device to make a phone call in the 1900s to Sears and Roebuck and order whatever it is you wanted from their catalog, which, by the way, usually sat in the outhouse and doubled as toilet paper back in the day. But you could use this to order anything from that catalog. So my question is, this is commerce, a transaction. It happened electronically. Was that e-commerce? Do you know? What do you think? Is that e-commerce? You think so? Anybody think it's not? Who thinks it's not? Who thinks it is? Okay, you guys just don't know. Non-committed. All right. Well, I'm going to tell you there's no right answer. So what if I call in, I go to a website. So you mentioned until you get to checkout, right? I go on a website, I find a product I'm looking for, and I don't want to give my credit card online. But there's a phone number at the top of the website, and I call that phone number and I tell them what I want to order, and somebody on the phone takes the order, types it into their computer system, it gets shipped to me and everything. I didn't make the transaction online. So by your definition, that would count as e-commerce, right? Okay, anybody else? Is that really e-commerce? You think so? Okay, all right. Let's keep going then. So I have to confess, this is one of my vices. I'm sitting in McDonald's. You can even see what I ordered, I guess, the large fries, right? Way too many calories. And I order online, and I'm sitting in the restaurant itself, but I have the app open. I make my order on the app, and I pay on the app, and somebody brings me my food. Have I committed an act of e-commerce at that point? I'll say, even though I'm sitting in McDonald's, I could have gone up to the counter. All I used the app for was because I was too lazy to get up and go to the counter and order. If I had ordered that same food at the counter and paid with money, is that e-commerce? But there's very, very little difference between that and this, right? So somehow this and this is everything, including the transaction, except for the delivery. So, okay, all right, we think that's e-commerce. Amazon, embarrassingly, has this definition of e-commerce on their website. And I'll let you read this on your own, but I would point out to you that they use the term internet superhighway. When somebody uses a term like internet superhighway, I assume they're either a scammer or a boomer. I don't know which. By the way, I'm not a boomer. It's trading of goods and services on the internet. So for them, it has to be on the internet. But if I have an app, I'm kind of on the internet. So it just kind of depends. Like things start to get fuzzy around the edges, right? So I think we would all say, okay, Amazon.com, if I buy something from Amazon, that's e-commerce. Everybody agrees with that, right? Okay. If I buy from sites that are like Amazon, I'm still in the big circle at the very center of e-commerce, right? Something like that. Okay. What about Uber and DoorDash and Lyft? I'm buying a service. Okay, so for you guys, services are e-commerce. Even though I'm on an app, I'm not on the web, it's still e-commerce for you. Okay. All right. What about I'm playing a game on my phone and I can buy, anybody here played Candy Crush? Have you ever bought anything in Candy Crush? Okay, you can like buy levels or something, I don't know. Sounds like you're a fan. Okay. What about Tender? Because there, I'll be honest, I've never used Tender, so I'm going by what other people tell me. But you can like enhance your membership, and I think you even have to pay for a membership, right? So no, it's free? Oh, okay, but you can spend money on Tender, right? Is that e-commerce? Okay, it's because it's an app. All right. Now, I'm going to get to the most obscure version of this. My wife, by the way, is the queen of Facebook Marketplace. She has bought and sold everything on Facebook Marketplace. Sometimes we even get stuff for free, right? So she doesn't like the clock on my office wall anymore. She takes it down, shoots a few pictures of it, puts it up on Facebook Marketplace. And on Facebook Marketplace, she lists it for $30. I don't know, whatever. And somebody goes on Facebook Marketplace, they like the clock, they tell her they want it, they're going to come pick it up. They come pick it up, they pay her cash for the transaction. Is that e-commerce? You have a very large one. You say no. What about you guys? You were non-committal before. That's not e-commerce? You say yes, you say no. Why do you say yes?
Because most of the transaction happened online, not actually giving the money, but like getting it set up to sell.
Okay.
Happened online.
Okay. And you say no. All right, let's hear you.
The physical payment is online,
Okay.
and you don't need the internet you need the internet to contact the person, but not to pay.
Right. Okay. Yeah, it's kind of, so it's hard to know. And by the way, I'm not advocating either position. I think either one is fully valid. But it's hard to know because I could have done the same thing by putting the clock in my yard saying $30, right? And somebody could have come by and picked it up. Nothing would have happened on the internet. What about like if you're selling something on Craigslist where it's even less internet involved? You just throw a picture up there. Same thing, more or less? Okay. But I think what we could say, like maybe there are degrees of e-commerce. So some stuff is like definitely e-commerce and everything in here. This stuff starts to blur the edges a little bit. Now, let's try another one. I go into a convenience store, let's say in Austin, Texas. You guys know, like they have all those little convenience stores. They're called Blue King or something. I can't remember what they are, right? So you go in there, and I grab my Diet Dr. Pepper out of the refrigerator, take it to the cashier, and they have a point of sale system, which is like just a little screen, right? And I put my card in there, and I make my purchase. Is that e-commerce? Because that entire transaction took place over the internet. They use a system called Stripe. Stripe is the same thing that you check out with when you go to an e-commerce website. In many cases, my company uses it quite a lot. Many of my clients use it. It's the same thing, but part of it took place on the internet, right? It's kind of the opposite of the McDonald's example. Like I grab the product, but then I pay online. I'm literally paying online. Although there's really no difference to me, as if I had, if they had one of those little swipe machines, right? So I think, defining e-commerce, you've got to think about it. E-commerce sort of permeates almost all business now. There are very few actual e-commerce businesses, or rather I should say there are very few businesses that do not have an e-commerce component. So it's a component of just about everything we do. All right, let's move on to our next term, artificial intelligence. Anybody want to take a shot at defining this? Anybody? No. All right. Come on in. Yeah, this is a tough one, right? And in fact, artificial intelligence researchers hate the word artificial intelligence. They like to break it down into components like machine learning and things like that, because they don't think that artificial intelligence is really intelligence, at least not in the way that humans are intelligent. It's a very different kind of thing. So the word intelligence is a bit of a misnomer for them. Now, I'm going to prove to you that artificial intelligence has been around for a long time, even before I was born. And there was a very famous quote by a person you may have heard of. Can you guess who said this? That he said, if you have to choose what you're going to search, and if you don't choose, well, you're going to waste a lot of energy. But things actually unfold slowly over years. Who do you think said this, and what do you think they were talking about? Any guesses? Go ahead. A hint? You probably have and use daily the technology that he's talking about.
Steve Jobs.
Okay, Steve Jobs. What do you think he's talking about?
Or just the internet in general, like the iPhone, just internet.
Yeah, he was actually talking about the iPhone. This was a interview in 2008 when the iPhone was just coming out, and Steve Jobs said. So if you think about it, to us, to me especially, like I knew about the internet, I knew about phones, obviously, right? And we had portable devices, we had iPods back then, right? But we get these devices, but to the world, and to the news media, it was like, oh, this happened all of a sudden. All of a sudden, there was the iPhone, right? And not really. Like people had Blackberries for a long time. Like it was a different configuration. And so Apple was not the first. There were other smartphones before Apple, before the iPhone. They just happened to make it very, very popular and more, very consumer friendly, easier to use, et cetera. And so it became like a really popular thing to do. And now we all have smartphones, whether they're iPhones or not. But going back even further than that, I'm going to draw a line in 1951. And the reason I'm drawing a line in 1951 will become apparent in just a minute, but keep that date in your mind, 1951. Before 1951, we were kind of dreaming about, talking about artificial intelligence. But after 1951, we're actually in the age of sort of developing artificial intelligence, what we would call artificial intelligence. So, and I apologize to any computer science people in the room for using the term artificial intelligence. 100 years ago, a gentleman wrote a play, and actually, let me get his name. I think I have it. Named Karel Čapek. Karel Čapek was a Czech playwright, and he wrote a play that became known. Became very popular. It was translated into 31 languages, performed all over the world. It was called Rossum's Universal Robots. And the interesting thing about, and I don't think this was from the original play. It appeared for many years. There's actually a version of this on YouTube if you want to watch it. But this play is where we get the word robot. This was when it was introduced at least into the English language. Now, robot is a derivative of a term I'm going to mispronounce, robota, which was a Czech term which meant serf. So almost the equivalent like a slave, right? Like you all know what a medieval serf, S-E-R-F, is. And they saw these robots coming up as, they built them to do the jobs that people didn't want to do. So they essentially became slaves. But eventually the robots get smarter and smarter and smarter, and it creates a lot of problems with them. So I won't ruin it for you. If you go on YouTube, look up Rossum's Universal Robots, and you can watch this. But it did foresee a number of problems that we have experienced recently. Whether it's safety in AI, plagiarism, you've probably heard about displacement of jobs. Everybody's, we're all up in arms because it's going to take over everybody's jobs, et cetera. Some of them chat bots have been racist. I mean, there's been all kinds of stuff going on, right? All of these things were actually foreseen in this play from 100 years ago when they didn't even have a computer to think about. So it's really kind of amazing, and I think it will, if you watch that, it will give you a chance to think about some of the things that we're doing with artificial intelligence. Does anybody recognize this image here? Anybody know what this is? Okay. This was a very early computer. It was built in the early 1940s by a man named Alan Turing. Does that bring it to anybody's mind? Alan Turing? So this computer was used to crack the Enigma code, which was the Nazis' secret code. They had these machines that they could type into, and it would create these codes. And they were using this to crack that code, and they did so successfully. The interesting thing about this computer was these little things that you see here wired in. They're actually mechanical relays. They're like these little switches. And so this was even before like the computers you've seen with the tubes in them, et cetera. Again, we're in the early 1940s. But Alan Turing was known for another thing that he did and thought about, which was called the imitation game. Some people call it the Turing test. Does that mean anything to any of you? No? So the Turing test goes like this. So again, we're pre-1951, so we're just thinking about artificial intelligence. We're not really doing anything about it yet, right? And Alan Turing says, okay, you can set up this game called the imitation game. I'm going to have a person on one side of a partition, and then I'll have a person and a computer on the other side of the partition. And person C is going to pass images through the partition. And when the response comes back, if person C cannot tell if it originated from the computer or from the person, then the computer wins. And somehow we've extrapolated that means that we've achieved, generalized artificial intelligence, which is another term that researchers hate, AGI. But this is where that idea came from in artificial intelligence, and it was called the Turing test. And a lot of people, a lot of media refer to this. AI researchers, they're like, it's not really a very good test. Does anybody feel like sometimes when you all use AI, right? Like you've all used an LLM like OpenAI or ChatGPT, something, right? Or Grok or Anthropic, whatever, right? Does it ever feel to you like sometimes it's like there's got to be like a person on the other end because of the way it responds? No, you know it's a computer. Okay. So to me, sometimes like the conversation feels like a conversation I might have with an intelligent person. But that was Turing's test. And if we get to 1951, finally, there was a researcher who was a man by the name of Minsky, and he was working in a lab, and he worked on electronic things at that time. And some of his researchers in the same university were actually doing experiments with mice, and they were training mice to navigate mazes and to figure out like how to go, or not mice, rats, sorry, they were rats, to go through these mazes. So, you think about it, the rat has to make a decision at some point. So there's this decision point, and Minsky says, hey, I wonder if I can create a machine that does the same thing. So he thinks about it for a while, and he thinks about like how this might actually work, how the machine could learn to make decisions, etc. And he produces this thing right here. It's called the snark. And the snark is made out of a few tubes. It never worked really well. In fact, the decisions whether to turn or to go straight were relatively poor, to the point that it was about the same as just flipping a coin. I mean, it just seemed random. It didn't seem like it was really learning anything at all. But he built feedback mechanisms in this so that it could potentially learn, and they thought that this machine was actually going to learn. And this was actually the first neural net. Now, Minsky becomes extremely important because in 1959, he becomes the head of the Massachusetts Institute of Technology's Artificial Intelligence Research Lab. And he continues to work on this idea of replicating a neuron or a few neurons, and he calls it a neural network. Now, a few years later, there are a couple of researchers from the Ukraine that come up with another idea, and they come up with a software way, and this would have been in 1960. I have the date right here. Let's see. This was 1956. So a couple of researchers before the two Ukrainian researchers, there were two researchers at Carnegie Mellon. And these two researchers at Carnegie Mellon wrote software that could actually prove theorems, mathematical theorems, and it was actually able to prove about 38 of, at the time, 52 unproven mathematical theorems, ones that people accepted, actually produced proofs for them using a form of artificial intelligence. And then I don't have the names of the gentlemen in the Ukraine, but in 1965, there were two researchers there who created a way of training a neural network that is kind of the opposite of what we use today. And I'm actually going to walk through a little bit of how you would train that in a minute. In 1970, Stanford University, does anybody have an idea what this could possibly be? Any thoughts? This is actually the first autonomous vehicle. So this is 1970 with computers that we had in 1970. So we actually had like microprocessors in silicon by 1970. They were able to create this computer, and it had a camera, and with the use of vision and motors, et cetera, on its own, it could actually make its way across a room littered with chairs in about 4 hours. So not particularly impressive by our standards, but it was an autonomous vehicle, and the computer was able to do it by itself, seemingly making autonomous choices. 1997, I think it was, IBM created a computer called DeepThink, and it had lost several rounds to Garry Kasparov. Garry Kasparov was the grandmaster, the ultimate, grand chess champion of the world at that time. But in 1997, he actually beat Kasparov. And since that time, machines have far surpassed the ability of humans to play chess. In fact, humans playing you really have to downgrade the machine's ability to play chess in order for a human to beat it now. I can't even beat another human, so I'm certainly not up there. But things start to get productive. So in 2009, Google introduces its autonomous vehicle. It wasn't very good. It can only go around, sort of little areas, but it was much better than that silly machine from Stanford in 1970 as far as autonomous vehicles go. In 2011, you might not know what Jeopardy is, but it's a game show. IBM creates a computer called Watson. Using artificial intelligence, it's able to understand what question is being asked and respond to the question. It was an early large language model. And we see throughout the 2010s the emergence of these large language models, including ChatGPT, right? That's the one you're probably most familiar with. And then in the early 2020s, Tesla's full self-driving actually becomes really, really capable. I actually have a Tesla, and I didn't purchase the full self-driving because my wife doesn't trust it. But I got a free month and we were able to try it out, and it was actually incredibly impressive, right? This thing could take me from my house to the gym, navigate school zones, navigate, whatever the obstructions were along the way, traffic lights, all that sort of stuff, without me doing anything. So we've really, really come, quite a long way in what we would call artificial intelligence. Now, before you say, okay, boomer, next time you meet somebody that deserves that, I want you to think about the generations we've been through. So my grandparents there was the first generation to grow up with electricity in their home, where most people had electricity in their home. My parents grew up with broadcast radio. So any sort of broadcast media was a new thing to my parents. My generation, sorry to say, the reason our minds are all mush is because we grew up with television, and eventually cable television and color television, all that. My kids, who are a little bit older than y'all, grew up with the internet. They cannot imagine a time when there was an internet. Now, when they were little, I used to drive around in my car in Dallas, and in the glove box, I had this book this thick with maps of Dallas, so I could find where I was going to. Nobody uses that, of course, anymore, right? You've never used that. You have a phone. You have GPS on your phone. The map tells you where to go and which bus to take, like we did this morning. But my kids grew up with that, which to me was just astounding, right? My grandkids, who are younger than y'all, they're going to be growing up with AI. It's a very different world that we live in. If you think about my great-grandparents, their parents, and their parents before them, and their parents before them, they all grew up with the horse and buggy, and they were all farmers, right? This is an amazing evolution, and it seems to accelerate. I mean, nobody would say, oh, woo, television, that's great, right? I mean, unless you're just desperate to watch something. But especially broadcast television, where there's no remote or anything like that. But as things start to accelerate, I can only imagine what the generation after you is going to think of you. Because AI kind of came about during your lifetime. Well, my AI journey was a little bit different than this. So when I was a kid, I was one of the few kids in the 1970s that had a computer in his home, and I didn't have it there for very long. We couldn't afford it because they were thousands of dollars. My dad actually rented one for about 3 months so that I could learn to program. And the first program that I encountered that was supposed to be intelligent was this thing called ELIZA. And ELIZA was basically like a computer interface, text interface, like you had to type everything in, that would ask you questions, and then it would, if it found certain keywords in your answer, it would give certain responses, et cetera. It wasn't very smart, but it was entertaining, and it did kind of seem like the computer was trying to talk to you. And in the 1990s, I worked for PepsiCo, and I worked in the marketing department at Pizza Hut. And I was responsible for a program that was driven by a data source that Pizza Hut had that nobody else had at the time. So this was before, you could not order a pizza on the internet at that time, right? The internet was very new, it didn't exist really. Nobody had figured out how you could possibly tie this internet into like an ordering system for a pizza, et cetera. It took us a very long time to really figure that one out. But we did have your purchase data. So if you were one of our customers, I had your phone number. So you called in every time. We would ask for your phone number. We would check. I had your whole purchase history. I could see what you bought. I could see everything about you. And so as a marketer at Pizza Hut, I was responsible for database marketing. I actually had certain information that nobody else had. There was no Amazon. People weren't buying online, right? And even people who purchased from catalogs, yeah, they had your history, but it wasn't, that wasn't something you bought very often. But pizza, you might buy that every week, every Friday, you might call in. And so we had all of this, what we called longitudinal data, or your purchase history. And we had a program. It was extremely profitable. It was called the heavy user restoration program, and it went something like this. So for 90 days, we would take your purchase history, and then we would have a computer spend about a week figuring out what everybody, and we're talking about over 100 million households, what their purchase history was. And we would put them in one of these 4 buckets. So if you ordered, about every week, you were a heavy user. If you ordered at least once a month, you were a frequent user. If you ordered, a few times during 90 days, you were considered a light user. And if you didn't order at all, you were a non-user. Made us cry. We sold pizza. That's how we made our money, right? So we used statistical means to figure out like who was in each bucket. It was very simple math, right, at the time. And then we found out that something, and when we implemented it, and I think it may still be in action today, but when we implemented it, Roger Enrico, who was the chairman of PepsiCo, said it was the most profitable program he would. If he could take every dime of the company and put it in this program, he would. Now, we couldn't use every dime, but it was extremely profitable. And what we would do is if you had been a heavy user for 90 days, and then over the next 90 days, you were a non-user, I would call you on the phone, offer you, not me, I had obviously a room full of people doing this, but I would offer you a buy one, get one free pizza. We would deliver it this weekend. You could make the transaction, right then over the phone. You could order the pizza. And we found that if we would do that, then the purchase behavior of the people that we called would reignite their heavy user, or at least their moderate user status. Enough of them would move out of this group that it was extremely profitable for us to do this. And you think about it, like the cost of that phone call and everything, but over the next 90 days, we would make a lot more money on those people than we would have if we had not called them. So we kept a control group out to the side that we didn't call, and we compared them, and we could say, hey, statistically, this whole thing's valid. It's doing its job as a program, and it had an extremely high return on investment. Well, my father when I took over this program, so my predecessor put up that program, and I said, it seems really restricting to me that we have to go from one end of the spectrum to the other. We call those people, with an offer, and we know that offer works, and that will help restart the purchase behavior of these formerly heavy users. And I thought, and Roger Enrique was saying he wanted to put more money in it, and I'm like, how could we put more money in this? And so I said, maybe there's a way that's a little softer that we could do this. And so my dad, this is a picture of him. He was actually a rocket scientist, said so on his business card. He had a PhD from Rolla. Anyway, he worked on a lot of stuff. This was actually one of the rockets that he developed. This is from the 70s, so 20 years earlier. But he was starting to create these control systems for missiles that would use a thing called fuzzy logic. And fuzzy logic was a form of artificial intelligence. Now, it's not neural networks. It's a little bit different. But the fuzzy logic would allow me to express my, or to describe my customers not in purchased, didn't purchase, purchased, didn't purchase. It would say, well, this person's kind of a heavy user, but not, they're 90% heavy user and 10% moderate user, or they're 50-50. They're somewhere in between, right? It allowed me to use more human terms to describe how these customers purchased, and I could go to a manager of a Pizza Hut who was already doing this. He would call up customers and offer them 10% off, or he would, because he knew, hey, I haven't seen this guy in a while, because he knew his customers, right? And so we could take what his intelligence, what he had learned from doing this, we could create a fuzzy logic system and a model to do that. And then, we were starting to experiment with all this when I left. Now, today, you use fuzzy logic. It's in almost every single device you have. You just don't know you have it. It's used in pretty much every single control system. Anything you have that has a fan in it is probably run by fuzzy logic. But I started using it back then to try to figure out a marketing problem, and it's used in many different problems, or in many different solutions today. Now, fuzzy logic is probably not quite as powerful as neural networks. And besides me saying that term, have you all heard the term neural network? No? Okay. All right, we're going to get on the same page. But before I can talk about neural networks, I need, so ChatGPT, large language models, those are based on neural networks. And they look at, so have you heard of any of these terms at all? Curious? No. Okay. We're going to go through them. I promise we're going to, you'll understand everything there is to know about machine learning when we're done here. So tokenization and embeddings. So embeddings was an idea that came from some language researchers who were trying to solve, initially they were trying to solve problems translating from one language to another one. And they were trying to relate words to each other. And so the entire dictionary has been, we have created embeddings for the entire dictionary of the human language and much of the internet. And they were looking at associations with words. They said, if I was able to take this, and they didn't even use words, they would say, if I was able to take this concept and convert it to something else, mathematically, this is what the math would look like. If I had a queen, well, let's just say she's a king, less a man plus a woman would essentially be the equivalent as far as they were concerned. Same like the hand, well, it's a foot minus a leg plus an arm, right? They would take these associations between words, and as long as the math worked out, then they could say, okay, so if these were numbers, then the math should all work out this way. I can take this, I can do these mathematical operations, and my output will be a hand or a queen, right? So that's the idea conceptually behind embeddings. Embeddings are taking concepts and turning them into numbers, but it's probably not the kind of numbers you think. But before I can do that, I have to break down my phrase. So I may have a phrase. The queen has a lovely hand. Okay, going back to hand. The computer is going to tokenize this. So when you're typing into ChatGPT, it's tokenizing what you're saying, and it's breaking it down into essentially this string of thought bubbles. And those then become the actual inputs into the large language model or the neural network. This is what one of those concepts looks like. So it's this long string, and there's actually 1,500 individual numbers that break up, a word or a concept or a phrase. And I can take these things and I can take a whole paragraph of these and add them all together from a concept standpoint. And it also looks at like where the words are in relationship to each other. But again, we're simplifying a bit. And if I plot it, this is like all 1,500 of those numbers plotted on a chart, and you'll see these huge spikes but there's more than one of them, and these spikes refer to a specific concept. Now, if I can break the English language down into 1,500 concepts, and going back to kind of my fudgy logic from before, how much does the word that I have match a specific concept? And that's what's happening here. Like here's a really high match. It's less, a really high mismatch because this is like less than that, right? But then I have one up here, et cetera. This tokenization here, it's called a vector. This vector is the same is actually the description of a welding machine from a website that I worked on. And we were creating a new way to search for products on their site. And so we tokenized, broke it up into its parts, vectorized it, turned it into math, right? Turned it into a stream of numbers. And so I have this. And what you use to do that are what's called embeddings. So this system enables a new kind of search because now, rather than searching for a specific term or a word from a sentence you type in, I'm actually comparing concepts in math, in numbers that have been created. So for example, and I rarely have a 100% match because I rarely express exactly what that embedding is, what that embedding represents, the thought that represents. It doesn't work that way. But what I can do is I take that text information, I tokenize it, I vectorize it, and I put that in a big long list, right? And what's a big long list? A database. So I put that in a database. And then while you're searching and you're typing in the search term, I'm also vectorizing what you're typing in. I'm turning it into that long string of numbers, right? And I'm also summarizing that, meaning I'm adding those numbers together, and then I'm comparing it to what's in my database. So if I'm searching for a welding machine that can be used in this situation for this amount of time and costs less than this amount of money, et cetera, I'm typing that all in as a phrase, and then it's looking in that list and it's saying what's the closest match to that. And it returns to me the closest match. So it's what is the most similar concept to this? And that's how we get to a machine that can learn, because it can compare concepts. And so if you think about language translation, which is an excellent example of one of the uses of LLMs, right, is that I'm actually comparing, like I have the same concept in Russian represents these words. In English, it's these words. Those are the embeddings. And so when those match up in my translation process mathematically, like I output this Russian, right? So now we're at the point where we can talk about neural networks and machine learning. And we're going to go through this really quick because I don't want to get into the math of it. But have you heard of weights? Weights? Okay. Do you know what a weight is? Or what was the context you heard of it? Math class. Okay. Okay. Well, you can think of a neural net, a neuron, a single neuron in a neural network as this. It does some math on two inputs. Here I got a 12 and a 24. In this case, each input is weighted to a certain amount, and then that creates an output. So if I do this math, so all I'm doing is multiplying my weights by the inputs here, and I get an output as a number. And I can do this with single numbers, or I can do it with those big old long strings of numbers, those can be inputs as well. And so this is like one neuron, right? It doesn't really produce that much. But I start to string these together so that the input, so the outputs of this set of neurons become the inputs for this set of neurons, and they all have incoming weights, and I produce math. I do math on that, very simple math generally at the neuron level, and it gives me a specific output. And the way that I train these things is I set them up so that I have layers. Now, this is a very small neural network. It has essentially like two columns, right? It has two layers. And then the first layer feeds the second layer, et cetera. When I'm looking at a large language model, there are billions of these nodes. But just think of these as individual neurons. And what I do is I take a set of data. And the nice thing about the set of data that I take is I already know the correct answer. So I already know what output I want if I provide this input. And so when I feed it through the neural network, it matches this output. And as soon as that output, which is the correct output, matches the input that I'm getting, I'm able to output a model. And how do I do that? Well, as I run through this list of known questions, let's just call them questions and answers, there's known questions and the known answers, this says, hey, this is not quite right. And so I have a computation that goes back and adjusts the weights coming in, and that tells me how that gets output. So hopefully, we're almost done with this, I promise. If you're falling asleep, I'll wake you up in a minute. But I hold out part of that, and then I run that through my model. So rather than giving it the answers, I have it produce the answers, and then a data analyst goes back, looks at those answers, and says, how close do those match the answers that I know are correct? And if it's really close, it's a good model. And there's a really famous training exercise. Have you guys heard about this one, the wolf versus the dog? So early on, this was in the 2000s, they were training a neural network to tell the difference between a photo of a dog and a wolf. And for a long time, it would recognize any dog versus any wolf except huskies. It couldn't figure out huskies. Now, does anybody have an idea why? It's actually somewhat funny. Every photo they had of a husky had snow in the background. And almost all the photos they had of wolves had snow in the background. And so their training set lacked diversity. It didn't have huskies in different situations, right? It didn't have wolves in different situations, which led to a bias in the training set. And so what they found out was it was just keying in on the snow. Oh, is there a picture of an animal on snow? That's a wolf. Right? As far as the neural net was concerned, that was a wolf. So they were able to increase the training set size, add new images, and resolve this problem. And it could reliably predict over 90% of the time whether it was a wolf or a dog. Large language models are essentially neural nets. They're trained on massive amounts of data, but they're neural nets and they're surrounded by other things. So this neural net will get an input, and the correct output for that input may be, I need to search for something on the internet. So the large language model goes, opens up a browser, right? Searches for something and returns it. Or I need to do some math. So it'll say, oh, I'm going to feed that out to a calculator, because large language models suck at math. They're horrible at math. They're not good at that. If you think about it, you go back to the vectors, what are they dealing with? They're seeing it like, do things match up and are they close, right? They're not figuring out exact equations, right? That's not what neural nets do. So large language models have that problem. And they can access file systems and vectors, but the way that they're trained is essentially, we've decided to take about a third of the internet, which is about 10 terabytes of text data, and we feed that through as if the answers are correct. Can you see a problem that maybe some of the information on the internet is not correct, right? That's why we have so many problems with large language models. It's because they're often trained on data sets that have incorrect answers in them. And currently it takes about $2 to $4 million in a whole room of computers a few weeks to actually train a model like that. And then the model that comes out is huge. This is a particular model. In practice, getting to your life. So a typical job of somebody in e-commerce is to catalog, to get products online. Have you all taken a class? You will take a class, right? Where you create an online store and you do all that, right? So I'll tell a story about Alice. Alice, she gets 1,000 products from a vendor in a Google sheet, but the information's not that great. But the Google sheet actually has embedded artificial intelligence in it to do some of the functions it does. When she got the email that told her that she had this Google sheet waiting for her, it actually put it at the top of her inbox and made sure that wasn't counted as spam, and that's all artificial intelligence that's doing that, or involves a lot of artificial intelligence. So even before she starts work, artificial intelligence has been working for her. So first thing she does is she takes this spreadsheet, she puts it into OpenAI, and she asks ChatGPT to make category assignments for her, because the stupid vendor, what did they not do? They didn't make category assignments, and she needs to categorize the products so you can find them on the website. So she does that. And she's got a bunch of images that are not in the correct format, the quality's not that great, etc. She uses a product called Adobe Sensei, which is another artificial intelligence agent, and it adjusts the images for her so that they are properly formatted for the web store. Then some of the descriptions were cut off, copy and paste errors, they have HTML in them, there's all kinds of stuff wrong with them. Alice runs the descriptions through Bard or through Gemini probably now to adjust those descriptions and make them usable on the website. And then finally, right, she's using, they didn't provide any short descriptions for these products. So Alice has ChatGPT write short descriptions from the long descriptions that are less than a certain number of characters. So this is how we use it already today, right? Like, this is a typical day for somebody. And I don't know if you as a student, you probably use some of these tools, right, to help with your work. Like, have you ever asked, ChatGPT to proof a sentence or help you write something? I do it all the time. And I don't consider it cheating, in my job anyway. And this is starting to get better and better. So it used to be, to get a good description and to get OpenAI to give me a good description, I would have to feed it a previously written description that was not good. This was written by ChatGPT-4 from this photo. I put this photo in and I said, hey, I need a description of this product on my website. Can you write one for me? One thing you'll notice so I'm going to show you the latest model. So this was the last time I taught this class. It looked like this. I'm going to show you the latest model, which is GPT-01. And you'll notice some things are different. So take just a second and just kind of scan that or read it a little bit. Give you a couple more seconds. Okay. All right. Now, GPT-01. What do you notice about the difference in the descriptions? Anybody want to say? Yeah.
The tone is different. It's well, it says persuasive, but it's
Exactly. Yeah. It's persuasive, right? It's learning to write persuasive and not just descriptive language. That's pretty cool, right? That's a huge advance in just the past 6 months that we've seen. So, yeah, is this going to be a game changer? You will see statistics like this, right? It can solve 92.8% of PhD level physics problems, right? And they'll compare it to the previous models. And maybe this is a good way of comparing to the prior model. But the score is not a score that it can pass the LSAT, or it can pass the bar, right? Which is the test that the lawyers take before they can get their license to practice law. Things like that, you'll see, well, the reality is it doesn't pass it every time. It doesn't get these right every time. They give it a certain amount of time to solve the problem. It submits answers until it gets one right. So this is just, could be 1 out of 1,000 submissions or 100 submissions that it gets it right. So it's not quite as smart as maybe the statistics that you'll hear from the media describe, but it is getting better, right, over time. And is this latest, there's a lot of controversy about this latest model, 01, because basically what it's doing is it's just prompting itself. So it's like writing subsequent prompts to give a better output. And then when it gets to a point where it's either taken too much time or it's kind of run out of new ideas, then it stops. It's usually like 3 or 4 or 5 iterations. It stops and gives you sort of the best output that it's been able to produce. So nothing in the model has changed. They haven't really retrained the model. They've just told the model to iterate, to go through multiple times. And we still have a lot of challenges for artificial intelligence: accuracy, bias, power usage, etc. Power usage is a huge one. I don't know if you've noticed, but there's been a push to return nuclear power in the United States. And if we're going to win in AI versus China or other countries in the creating of the AI, we're going to need a lot more electricity, because this stuff takes a ton of computation power. Now, today, it takes a ton of computation power. We may, Meta AI has said that they use less than 10% of the power from the other models because they have better incoming data. So it's a little different. But basically, power usage is going to be a big problem. My rule, we call it the rule of Paul if you wish, is we call new phenomena by something until it becomes ubiquitous. So the little rectangle you have in your pocket with a screen on it, what do you call it? You call it your phone? Does anybody call it your cell phone? No, you don't call it your cell phone. Who calls it their smartphone? No, you call it a phone, right? This is a phone. This is the phone I grew up. I didn't have a pink phone, but that's what it looked like when I was a kid. And so we went through these subsequent descriptions, but basically now every phone is a smartphone. And the reality is the phone is the least used app on your cell phone. So getting back to Steve Jobs' quote on this, these things happen over a long period of time. You're going to be fine. Nobody's coming for your job. You are going to have to learn to use AI, but ignore the hype. Listen, be careful about who you listen to. If you get into this field at all, listen to people more like Mark Andreessen and less like Sam Altman. Sam Altman is a salesman. Understand how it works.
Sorry.
Yeah.
Do you mind explaining who they are?
Oh, sorry. Mark Andreessen. So Sam Altman is the CEO of OpenAI, which is ChatGPT. Mark Andreessen is heavily involved in research, but he became famous because he created the first web browser company. So that was Mark Andreessen, but very involved in the investment in AI. Andrej Karpathy was the head researcher at OpenAI. He left about a year ago. Jan LeCun is the head of research at Meta's AI, and he's also professor of artificial intelligence research at Columbia University. I don't really like Jan LeCun. He's not a nice person, but I think he has a really good perspective about AI. Lex Friedman, anybody here? You might have heard of Lex Friedman. Lex Friedman's a podcaster, but he's also a researcher at MIT on OpenAI. All of these people explain things very well. So if you can look up a podcast with their names on it, and you're going to provide them with slides, right? So you'll be able to see these. Also pay attention to the large language model company blogs. But try out the AI tools. Use multiple ones of them. And just understand this is part of your future. And maybe it's just natural to you. It's not to me. Right? I have to convince myself that I need to give in to and collaborate and embrace AI, which I have done. I kind of turned the corner a couple of years ago. But for you, it's not. There won't even be a question. As you get into your careers, everybody's going to be using AI for something. So appreciate you attending this, and we've got a few minutes left.